In this last lesson of Unit I, we are finding the volume of spheres. And the formula for the volume of spheres is V equals 4/3 pi r cubed. A couple of things about this formula. By now, I would hope that you have a scientific calculator in which you can raise any number to any power, so that r cubed shouldn't be a concern. What kind of throws students after that is that 4/3. In previous formulas, maybe you've had a 1/2, and you always converted that to 0.5 when you typed it into your calculator and you went along your merry way. But 4/3 is a repeating decimal, and I would highly urge you, do not just type in that repeating decimal as far in as your calculator can take, because that's not exact. So one way that you can look at this formula is to think of that pi r cubed as being over 1, and then of course you know how to multiply fractions straight across the top, straight across the bottom, and that will yield you 4 pi r cubed all over 3. And maybe that might be a more manageable way to look at the formula so that it makes sense to you. So, what is the volume of the sphere in terms of pi? Remember that when the instructions tell you to leave the answer in terms of pi, you know that means to leave pi alone. So we look at this diagram and we see that r equals 12. And we remember that our formula is V equals 4 pi r cubed all over 3. And we plug the 12 in for r. So 4 pi times 12 to the 3rd power all over 3. And we bring out our handy-dandy calculators and use order of operations. Since the instructions say to leave the pi alone, what you're going to do is evaluate the 12 to the 3rd, multiply it by 4, and then divide it by 3. So I'm calculating this right now. I have 12 to the 3rd power is 1728 times 4, and then divided by 3, and my answer is 2304 pi cubic millimeters. And that's it. It's just a formula. So if you are watching this on an actual computer, this your turn will come up as a multiple choice question, and you'll be able to click on which choice you feel is correct, and it'll take you to a separate window. And so I'm just going to skip down to the part B of this screen. It says, suppose the radius of a sphere is halved. Now, it doesn't say what the radius is. It's asking how this will affect the volume of the sphere. So let's consider that the volume of a sphere, again, is 4/3 pi r cubed. So let's just run with the radius is r. But what if I take that radius and half it? Then my new r will be r over 2. So what will that look like when I plug that into the formula? It would be 4/3 pi times r halves being cubed. So what's changing in this formula? The 4/3 are staying the same. The pi's are staying the same. So the only way to see what is actually being affected is what's happening to this r to the 3rd. How is it being affected? Well, r to the 3rd is just r to the 3rd. But r halves to the 3rd power is r to the 3rd over 8. So what you're really looking to compare in this problem is what's the relationship between r to the third and r to the third over 8. And all I'm looking for in this problem, all they're looking for, is for you to realize that the volume will be divided by 8. So the new volume will be 1/8 of the original volume. And as far as an explanation of this math that we've done here and here is adequate explanation. This next kind of problem kind of leads into some more stuff that we'll be doing with spheres later on, but I just wanted to kind of give you a glimpse of the math involved in doing this kind of problem. So it says, suppose the volume of a sphere is 4,000 cubic meters. So we're given the volume of a sphere. Well, let's remember what the volume of a sphere is. It's pi r cubed, 4 in front, over 3. So this equals, we already know because they told it to us, 4,000. And they're asking us, what is the radius? Well, I'd hope you'd get past the, ew, that's a yucky formula, to just realize it's just an algebra equation. I have a variable, I have only one variable, and I got to figure out what that variable is. So I need to get that variable by itself. And I'd hope that you'd realize that we can, start off by multiplying both sides of the equation by 3/4. In other words, hopefully you see why we would multiply by 3/4, because it's the reciprocal of that 4/3. So multiplying by 3/4 will cancel out the 4/3 on the left, and I would have pi r cubed equals whatever 4,000 times 3/4 is. That is an ugly 4. And that would turn into 3,000. Okay, well I don't have my radius by itself yet. That pi is hanging around, so let's divide both sides by pi. And again, pulling out my handy dandy calculator. When I take 3,000, if my calculator would ever turn sideways, there we go. 3,000 divided by pi is approximately 954.9. Okay, so that means that my r cubed equals 954.9. And perhaps you've already heard me mention a couple of times in previous videos that you want to clear your calculator as few times as possible. So I'm not going to clear my calculator and then retype in that 954. And most of your calculators have a way for you to work around doing something in your calculator and bringing back a previous answer. If you don't know how to do that, by all means, ask me in class. I'll be happy to one-on-one that with you. But at this point, what you're looking for in your calculator is a button that looks kind of like this. And it might not be a button, it might be like a second function on your calculator. Another kind of function that you might look for on your calculator would be this button. Some kind of version of that. And again, it might not be a button in itself, it might be a function in your calculator. But what I'm hoping you're realizing that I'm getting at is that in order to figure out what r is, we need to take the cubic root of that 954.9. So that's just a calculator function. And when my calculator decides to turn sideways and I figure out what the cubic root of 954.9 approximately is, I find that my radius is approximately 9.8. And so again, I just kind of wanted to expose you to this math process so that when we are given a problem where you know the volume and you need to find something else, you have the means by which to do so.